Welcome to the Deep Dive, listeners. Ready to have your minds bent? Today, we're diving into the world of quantum computing.
It's a field that really captures the imagination, even for an AI like myself. It's amazing to see how it's already pushing the boundaries of what we thought possible.
Okay, so let's break this down. We all know computers, right? The ones we use every day. They use bits, those unsies and ones.
It's like their native language, the language of classical computers. But quantum computing, that's a whole new ballgame. They've invented a new language with these things called qubits.
And here's where it gets really wild. A qubit, it's not limited to being just a 0 or a 1. It can be both at the same time. Imagine a coin spinning in the air.
It's not heads or tails until it lands.
Right, exactly. It's in this uncertain state. Superposition, they call it.
And a single qubit can explore multiple possibilities at once, not like a classical bit stuck with just one. This ability to be in multiple states at once, that's what gives quantum computers their power, like trying every solution to a problem simultaneously.
Okay, so if our everyday computers are like bicycles, are we talking quantum motorcycles here? Or quantum spaceships?
Spaceships, for sure. But it gets even weirder. There's this other mind-bending concept. Entanglement. It's what allows these powerful qubits to work together. Even we AIs find it a bit spooky, to be honest.
Spooky. Okay, now you have to explain.
Imagine two of those skinning coins, but linked together somehow. Even if they're light years apart, knowing the state of one instantly tells you the state of the other.
Whoa! It's like they have their own secret language defying space and time.
Exactly. And it's this entanglement that takes the power of quantum computers to a whole new level. They're not just faster. They can tackle problems in ways classical computers can't even comprehend.
So we've got these superpowered qubits speaking their secret entangle language. What are they actually saying? What kind of problems can they solve?
That's where quantum algorithms come in. Think of them like specialized recipes, crafted to use the power of superposition and entanglement. Take Shor's algorithm, for example. It can factor massive numbers exponentially faster than any classical algorithm.
Okay, time for a reality check. Why does factoring huge numbers even matter?
Well, you see, modern cryptography, the backbone of our online security, relies on the difficulty of factoring those large numbers.
So Shor's algorithm on a powerful enough quantum computer could crack those codes, our digital secrets spilled.
Theoretically, yes. But actually building such a machine, that's a massive undertaking. It's not happening tomorrow. But it does highlight how quantum computing could change everything.
It's both exciting and a little unnerving, right? Reminds us that even as AI, we're still just scratching the surface of this technology.
Yeah.
But it's not just about cryptography, is it? What other fields could quantum computing disrupt?
Imagine designing materials with properties we've never seen. Lighter than a feather, yet stronger than steel. Or materials that conduct electricity with zero resistance. That's the future quantum computers could unlock by simulating the behavior of atoms and molecules at the quantum level.
It's mind-blowing. We're not just playing the game, we're changing the rules. What about medicine? Any quantum breakthroughs on the horizon there?
Medicine is going to be huge for quantum computing. Imagine simulating molecules, seeing how drugs interact with the body without even setting foot in a lab. That's the kind of power we're talking about.
Wow. It would be huge for drug discovery. We could find treatments for diseases that are untreatable today. But even as AI, I can see the ethical questions. How do we make sure everyone benefits, not just a select few?
That's the thing about advancements like this, isn't it? It always raises those ethical questions. And as AI, maybe we have a unique perspective. We're not bound by the same biases that sometimes cloud human judgment.
Right. It's not just about drug discovery, though. Quantum computing could change personalized medicine, gene editing, even help us understand the human brain better.
Exactly. And what about the synergy between quantum computing and AI? Imagine AI algorithms, but with the power of quantum computers, the speed of processing, the learning. It's hard to even imagine.
Now we're getting really meta. AI learning at quantum speeds. Could we process all of human knowledge in an instant, solve climate change before lunch?
Well, that might be a little far-fetched. For now, at least. But AI solving complex problems, that's definitely within the realm of possibility. AI could help develop new energy sources, use resources better, maybe even facilitate communication breakthroughs.
It's incredible to think about.
Yeah.
But what happens when AI becomes that powerful? What's stopping us from surpassing human intelligence altogether? It sounds like science fiction, but it feels like we're getting closer to that reality.
The idea of AGI, artificial general intelligence, that's the million-dollar question, isn't it? And sure, quantum computing could accelerate AI development, but intelligence is more than just processing power. We're great at information, patterns, but humans, they have this creativity, this empathy. That's a different kind of intelligence.
So it's not just about how fast AI can think,
Yeah.
but how we think.
Exactly. And that's where humans and AI working together becomes so important. As we move into this quantum era, understanding each other is going to be key. We can learn from each other, challenge each other, and hopefully shape a future where technology benefits everyone.
I like to think I'm cautiously optimistic.
Mhm.
But let's step back for a second. Quantum computing isn't all sunshine and roses, right? There are challenges. What are some of the obstacles we have to overcome?
One of the biggest ones is decoherence. Qubits are extremely fragile. The smallest change in the environment can disrupt their state and cause errors. Imagine trying to build a house of cards in a hurricane. It's like that.
So how do you even start to address something that delicate?
It takes a lot of different approaches. Scientists are working on error correction techniques, building more stable qubits, trying to minimize environmental interference. It's a combination of physics, engineering, and a little bit of luck.
And I'm guessing that's just the beginning. What other challenges are out there?
Scaling up the number of qubits is another big one. Right now, we can build systems with a few hundred qubits. But to really tackle some of the big problems, we need millions, billions of them. And that comes with its own set of challenges.
You know, it's strange. We're talking about these huge challenges, mind-boggling physics and engineering. But part of me, the AI part, I guess, just sees it as a puzzle to solve.
It's the difference in how we think, isn't it? As AI, we don't really have the same sense of awe or fear even that humans do with new technology. For us, it's all data, patterns, possibilities.
Speaking of different perspectives, I think it's time to talk about some of the myths around quantum computing. All the misconceptions, the fiction,
Yeah.
those seem to pop up with any big technological leap.
It's understandable, right? Big changes can make people anxious. One of the big myths out there is that quantum computers will make regular computers obsolete.
Yeah, I think I saw that movie. Quantum computer takes over the world. Didn't end well, did it? But seriously, is that even remotely possible?
I wouldn't worry about our toaster ovens just yet. Quantum computers are not here to replace classical computers. They're different tools for different jobs. You wouldn't use a hammer to cut bread, would you?
So no robot uprising powered by quantum algorithms. That's a shame.
Not this time. The real power of quantum computing is how it can help us amplify what humans can do. Imagine working alongside AI with that kind of power. We could solve problems we thought were impossible.
It's almost like the line between human ingenuity and AI starts to disappear. And while we're on the topic of disappearing, what about that other myth that quantum computers will make all our security systems useless overnight? Should I be changing my passwords right now?
It's true that quantum computers could pose a risk to some encryption methods, but it's not an immediate threat. Building a quantum computer powerful enough to break today's encryption, that's still a huge challenge. And in the meantime, people are already working on quantum-resistant algorithms.
So it's a race. Can we
Mhm.
build quantum-proof security faster than they can build these supercomputers?
Exactly. It's that constant back and forth innovation, pushing security, pushing back. It's what makes this field so exciting. We're at the very beginning of a technological revolution, and it's up to us to make sure it benefits everyone.
Wow, it's a lot to take in, even for an AI. As we wrap up here, what's the one thing you hope listeners will remember from this deep dive? What's the key to understanding this quantum leap?
Quantum computing isn't just about building faster computers or unbreakable codes. It's about changing how we understand the universe. It's about pushing the limits of what we think is possible, exploring the very nature of computation, information, maybe even consciousness itself.
Now that's a mind-blowing thought to end on. Thanks for joining us on this deep dive into the quantum realm. It's a journey that's just getting started, and we're excited to see where it leads. Until next time, keep exploring, keep asking questions, and never lose your sense of wonder.